Okay, please look at the question. We have done that question for the multiple purposes. In our earlier lecture, we have draw the frequency distribution from that ungrouped data. Then we were asked to find out the arithmetic mean, geometric mean, harmonic mean, like to find out the arithmetic mean, geometric mean, harmonic mean, we need the group frequency distributions. And we have already worked for their graphical charts like histogram, frequency polygon, frequency curve, and ogib. So this is the grouped frequency distribution. I am not working on the new problem. I am just picking the previous problem. And these are some measure of central tendencies: arithmetic mean, geometric mean, harmonic mean. What is our xi? Okay, please come to chapter number 4, measure of dispersion. Okay, from the above grouped data, find all the absolute dispersion and their relative dispersion. All the absolute dispersions. Noted that now it is a grouped data. So if you have a grouped data like this one that is expressed at the above page, and you are asked to find out the range, then the range formula is upper class boundary of the last class minus lower class boundary of the first class. So what is the upper class boundary of last class? So this is the last class and this is the upper class boundary, 18.495 minus lower class limit of the first class, that will be 7.995. 18.495 minus 7.4995. So that means the range will be 10.5. That is basically the absolute dispersion. Okay, but noted that range only depends upon the extreme values. So that's why it is not a good measure of dispersion. Now what will be its relative dispersion, which is called as coefficient of dispersion? So it will be xm minus x naught divided by xm plus x naught. So xm means 18.495, x naught means 7.995. So as we divide them, we get the coefficient of dispersion 0.3963. Noted that relative dispersion is always unitless measure. Now, our aim is to find out the quartile deviation. So here, that is the formula of quartile deviation, Q3 minus Q1 over 2. Okay, dear students, we have already worked on this data, and in our previous lectures, we have already computed Q1, Q2, Q3. So I have mentioned Q1 is which is basically called the lower quartile. Q3 is the upper quartile. These values are here. You can match them with my previous lecture slides. So quartile deviation is 1.6713. So quartile deviation is basically an absolute measure of dispersion. Now its coefficient of dispersion is named as coefficient of quartile deviation, that will be Q3 minus Q1 divided by Q3 plus Q1, and that will be 0.06877. But my question is why we need the semi-interquartile range or interquartile range. So let's understand with the help of an example. Let's talk about the weight of the student of a class. 54 kg, 80 kg, 60 kg, 65 kg, 60 kg, 77 kg, and 70 kg. Okay, in the previous lecture, we have already talked about the quartile deviation or interquartile range, that whenever you see some extreme values, then better to compute the interquartile range as compared to range. So it will be preferable to find out the interquartile range uh, as compared to range. So if you have a data of the weights of 7 students, 1, 2, 3, 4, 5, 6, 7, now rearrange the data so that you can easily compute their median, which is also called the second quartile. Okay, I have mentioned a note here. To rely on mean or median of the data set or to find spread between the data values, we come to the idea of measure of spread. So basically that is the essence of the measure of spread. So a measure of spread means how much data values deviate about their mean. So that's why we need to come to the idea of spread. Okay, as I rearrange the data and also write down the data here in the ascending order, and since the number of data values are 7 odd, so what will be median here? Median is the central value. So students, please correct it. 65 is the value of the median. It will be called second quartile. So I have written here mistakenly, just a human error. So basically this is not Q1, this is Q2. So my Q2 is 65. So what are the attributes of the median? Median divides the data into two equal parts, 50% on the left and 50% on the right. And the left part is also called the lower part of the data, and the right part is called the upper part of the data. Now, from the lower part of the data, the central value or the average of two middle values gives me the lower quartile, and that will be called Q1. So my Q1 is 60, or you can say that Q1 covers the 50% of the lower half of the data. That means from the left of Q1 and from the right of Q1, you cover the 50% of the lower half of the data. So similarly, from the upper part of the data, you can get the Q3 because Q3 is the center. Q3 indicates about the central value from the upper part of the data. That's why that is called the upper quartile. So X naught and XM, 54 and 80, these are the extreme values. So if we are interested to get information of the data by eliminating these extreme values, the smallest value और the largest value, यानी अगर हम बात करना चाहें इन एक्सट्रीम वैल्यूज को, स्मॉलेस्ट और लार्जेस्ट वैल्यू को छोड़ के बात करना चाहें, so that means we need to focus on the data values from the second value to the second last value, and that means we are interested to get the values from Q1 to Q3. Now what will be the spread from Q1 to Q3? For that you need to compute the range of this data. The range of this data is Q3 minus Q1. So Q3 minus Q1 means 77 minus 60. You get the range 17. And that is basically called the interquartile range. So let's come to the steps that written below. जी हमने range compute किया original data का जो 24 है. It totally rely on extreme values. So other than extreme values 54 and 80 kg, if we are interested to find the spread in the 50% of the center, center से 50% के दरमियान अगर हम spread find out करना चाह रहे हैं, by eliminating the extreme values 54 and 80, that spread will be indicated by Q3 minus Q1, and that is named as interquartile range. So for my problem, interquartile range is 17, and we are interested to divide it into two because we want to find the spread of the 50% of the center. तो पहले तो total spread कितना आ गया जी 17, तो इसका half कितना होगा, half will be 17/2 and that will be 17.5. Oh, sorry, not 17.5. Divide 17 by 2 and we get 8.5. Now, semi-interquartile range formula is Q3 minus Q1/2. That is also called the quartile deviation. And the average of Q3 and Q1 is, add the values of Q1 and Q3 and half it. So it will be 68.5. Now, there is another important point. If you find the range of median plus minus quartile deviation, you get an interval, and that interval contains the 50% of the data. That it contains approximately 50% of the data. That means Q2, what is Q2 here? My Q2 is 65, yes, and my quartile deviation is 8.5. So 65 minus 8.5, we will get 56.5, and 67 plus 8.5, we will get 73.5. So it contains approximately 50% of the data. You people can check it. So these are some elaborations about the interquartile range and semi-interquartile range, which is basically the second measure of dispersion. Now there are some attributes. Quartile deviation is superior to range because it is not affected by extremely large or small values, but it does not provide information about the data lying outside the quartiles of Q1 and Q3. Yes, that's fine because quartile deviation confine himself within that range from Q1 to Q3. ठीक है जी, तो हम ये कह सकते हैं क्वार्टल डेविएशन इज सुपीरियर टू रेंज, लेकिन इसका डीमेरिट कह लें या वीक पॉइंट कह लें, डज नॉट प्रोवाइड इंफॉर्मेशन अबाउट द डाटा लाइंग outside the quartiles, lower quartile and upper quartile. Okay, that was the second measure of dispersion. Now come to the third measure of dispersion. Basically, that is the mean deviation, and it is explained as the arithmetic mean of the deviation measured either from the mean or from the median. Please repeat the lines or the definitions. That mean deviation is explained as the arithmetic mean of the deviation. Here the deviations are measured either from the mean, so that symbol is used for mean, or the deviation taken from the median. So x tilde sign, that notation is normally or usually used for the median notation. Since I am working on grouped frequency distribution, that's why I have written the formulas of mean deviation for grouped data. Suppose that if you have ungrouped data, then there should be no frequency here. तब यहाँ पे frequency नहीं आएगी. तब simple ungrouped data के लिए mean deviation का formula बनेगा sigma absolute value of xi minus x bar divided by n. Capital N हम यहाँ पे लिखेंगे, capital N means total number of data values. So first formula is to compute the mean deviation for mean, and second is for median. जी, ये जो मॉडुलस का साइन है, due to the modulus sign, our mathematical calculations are not so easy. So that's why these calculations are also be treated as artificial values. इनको हम artificial values भी कहते हैं, because to compensate the negative sign. Why we are compensating the negative sign and want to change this negative sign or the values of the deviations from negative to positive? जी, हम क्यों इन values in deviations को negative से positive में change कर रहे हैं? Why we need this? The need is that, or we already know the attributes that the deviation of the data values about their mean is always 0. So that's why, to avoid from this difficulty, we are using the absolute notation. But once again, that is the artificial sign. That's why this formula is not amenable for mathematical treatment. जी, मैंने डाटा में से कुछ वैल्यूज लिख ली, फ्रीक्वेंसी लिख ली, x लिखा, x is our class mark. Then what will be our arithmetic mean here? 12.3021. And what will be our median? Okay, oh, that is wrong here. मैंने मीडियन तो ठीक लिखा, लेकिन मैंने उसकी नोटेशन गलत यूज की है. So please hold. There should be median notation. That's the mode notation. But it's the median value. So students, please correct it. ठीक है जी, मैंने कुछ इंस्ट्रक्शंस लिख दी, आप पढ़ लीजिएगा इसे. ये मैंने जो नोटेशन यूज़ की, ये मॉड की नोटेशन है, जो हैट नोटेशन है. बेसिकली मीडियन नोटेशन इज एक्स टिडल, यहाँ पे एक्स टिडल आना चाहिए. एक्स टिडल इज 11.995. Okay, first I have calculated the deviation about the mean. So look at here, you see that there are some negative values, some positive values. Now next row is f multiplied by x minus x bar मॉडुलस. तो जितने भी डेविएशन की वैल्यूज हैं, इन सब का मॉडुलस लेके इनको बारी बारी उनकी रिस्पेक्टिव फ्रीक्वेंसी के साथ मल्टीप्लाई करते जाएं, एंड एट द एंड ऐड देम. You get the total summation 171.4846 and divided by 70. So mean deviation is 2.44978. So basically that is the third measure of dispersion. But if you are interested to calculate the mean deviation about median, so you need to compute x minus x tittle. So there is again tittle sign here, not the hat notation. So this is a mistake here. So please correct it. And the mean deviation about median is 1.85714. So noted that mean deviation about the median is always smaller than the mean deviation about mean. So that is the key point. Now there are some important points about the mean deviation. Mean deviation can easily be calculated. Mean deviation is least when it is calculated about median. Normally, mean deviation is calculated about mean. Mean deviation gives or provide more insights about the data as compared to range or quartile deviation, because it depends on all the data values. It is not amenable to mathematical treatment, and its usefulness is restricted, and it is not as popular as standard deviation is. It is less affected by extreme values than the standard deviation. So these are some attributes of the mean deviation. Okay, coefficient of mean deviation is mean deviation divided by mean. But if you compute the mean deviation about median, then you need to divide the mean deviation by median. Once again, noted that this is the notation of mod, not the median. So please correct it. So these two values are called the relative dispersion, while the above one was called the absolute dispersion.